Hello everyone and welcome to another SuncatByte. This is a live lecture SuncatByte during lab hours. During this SuncatByte, we'll be talking about a couple things. We'll be talking about the ampersand operator or the address operator, and we'll be talking about pointers. So the precursor to this was the SuncatByte on data variables in memory, and understanding that there are 5 different properties for C++ variables, which we talked about during that SuncatByte. And those properties are, the variables all have a data type, so that's the sort of data it holds. An int, a char, string is a data type that we have a library for in C++. Then variables also have a value, that's what they hold. Then they have a name. When you declare it, you give it a name. That's how the programmer refers to it. They have a memory address, which is what we talked about last time. And then they also have an amount of memory that's reserved. That amount of memory that is reserved here is directly related to the data type, which we saw in the SuncatByte on data variables in memory when we looked at the size of operator. Okay, so then in C++, you know, each variable has a data type, name, value, and address, like we said. And when used with the data variable, the address operator gives the address and memory of the data variable. So if we use this and then we do a variable name like that, that's going to give us the address of the variable name in memory. And we'll see an example of this in just a little bit. But for now, that's all you need to know. So if we had int number like this, and then we had address variable number, that's going to give us or say we did this, cout this statement here is going to give us the number, the address of the number, which would be a hexadecimal number. Our addresses are in hex in C++, remember, or in computers in general. This is going to give us the value of number. All right, so let's see. Hey there, Simon. So we're just doing a SuncatByte right now. If you have any questions, let me know. So that's what the address operator is, the ampersand. We also have pointers. So a pointer is actually a data type. And it's a data type in C++ that holds a hexadecimal address or an address, such as okay, so then the pointer holds it. The pointer is used to hold the address of a specific variable and then when the pointer contains the address of another variable, it is said to point to that variable. That's why it's called a pointer. So pointers don't have their own keyword, but there is a specific declaration statement to declare them. Okay, and the program and the pointer need to know what type of variable address the pointer contains. So you have to tell it what to point to. The pointer needs to know what type of variable it's pointing to. And the way you do that is you specify the data type in the direct declaration. of the pointer. And in order to do that, you use the asterisk to do so, or the indirection operator. So the format for that is basically going to be data, darn it, lowercase data type, and then star, and then the variable name. So some examples would be float star x underscore pointer, or float star px, or float star p underscore x. So these are all pointers, and this says it's going to point to a float variable, and then these are all conventions that are used. This underscore pointer just denotes that it's a pointer. This p, it shouldn't be an L there. This lowercase p, then an uppercase x, denotes that it points to the variable x. Here we're basically saying we point to the variable x there, but that says it's a pointer. Here it's saying p underscore, it's another convention that just says we're pointing to x. So those are just some different declaration statements that we use when declaring pointers and conventions that we use. So say we want to declare an int and double variables and two pointers. So do that now. Say we want to declare an int and double variables and two pointers. So how do we do that? We say int a equals 75. That's just an integer variable like we've been doing all semester. Now if we want to declare a pointer to that, we say int a underscore star a underscore pointer. Say we want to declare a double, we say double b equals 82.0, and then we say double star b underscore pointer. Okay, so our pointers here are named this just by convention, basically to say, hey, I'm pointing to variable a, so you can keep track of where they're pointing. So C++ doesn't automatically assign that address, you have to actually assign it. And then assigning that address is the job of the programmer. So we'll see how to assign in the sample code. So if I look at this sample code and it's brand 3, we see the address operator here. And 525353. Let's look at 53, okay? So actually this one doesn't have a pointer, so we'll look at another example for that shortly. So this is just looking at the ampersand operator, which was the first part of this lecture. So we have a variable int n, it equals 42. We have double pi, which has 3.14159. Then we have a string, which is I love C++. Here we're going to write out the variables type, name, address, and bytes. Okay, so then, and the value as well. All 5 parts of a variable, right? So then we have the data, the type, the name, the value, the address, the bytes. So to output the actual data, or the value, that's going to be here. Then we have the address of n, which will be here. So that's the address, right? That would be this piece. And then we have the size of, which is going to give us the number of bytes that it's taking up in memory. And n is a integer. An integer should take up 4 bytes. Okay, so then a double is here. There's the value. This is the address of where that variable sits. And then this is the size, and a double should be 8 bytes. And then lastly, we have a string, and we have the same output there. And then also remember when we assign these variables, and they get assigned on the stack, this is from the SuncatByte on data variables in memory. When they're assigned when they're assigned on the stack, the one that's declared first should have the highest address. So N should have a higher address than pi, that should have a higher address than S when we run this. So if I build it, here we go. If I do a debug, or start without debug, here's what we get. So the data type of N is an int. Its name is N. It has a value of 42, which we assigned here. And here's the address. Notice this 00227FBC4, that's bigger in hex numbers than 0027FBB4. And notice 4 bytes like we said, 8 bytes like we said here. Okay, then the string is S. It has the value of I love C++, and then this is lower than that. So highest address, next highest, next highest. So now what if I wanted to use a pointer? So if I want to do a pointer, I would do it this way. Int star n underscore pointer. And then I want that to have an address. So I say, give me the address of n. Okay. So then if I came here, and instead of outputting that, I output star n, I'm sorry, n pointer, what do I get? You know what, better than doing that, let's do ampersand n. Let's do both of those. So notice when I do this line here that says address 001BF784, that is the pointer, because that pointer, which I declared here, has the address of n. Alternatively, I could just say output the address of n, which is this. So that's why this here, where I'm going over with my arrow, and this here have the same address. So that's it for this SuncatByte on pointers. If you have any questions, comments, or concerns, please do let me know. If not, I will see you during office hours, or I will talk to you soon. Or shoot me an email or the discussion board forum. All right, that's it. Talk to you soon. Bye.